Alright guys, this is for rationalizing the denominator inserts. The first question is 5 over 1 plus root 2. Now, as you can see on the denominator, we have a square root. It means it's irrational. Now, what's an irrational number? It's which cannot be expressed in a fraction form. Okay? Now, we can't really divide it by irrational number. So we need to change this to rational number. That whole process is called rationalizing the denominator. So we are going to do that right now. Now, only way we can get rid of this square root is by squaring it, isn't it? So to do that, we're going to use something called the difference of two squares. Hopefully you'll remember this. And then we will have to use a conjugate pair. Now, conjugate pair is the two things are exactly the same except that they have an opposite sign in the middle. So for example, for this one, the conjugate pair of this one is 1 minus root 2. So when I times that, I will square the each term. By doing that, the square root will disappear. Now, remember, we are not going to times by root 2 and the root 2 on the top and the bottom, okay? We are going to use conjugate pair, okay? So let's start. I'm going to use red pen, timesing it, 2, 1 minus. Now, the reason we're using the same expression on the top and the bottom, numerator and denominator, if you think about the whole thing, that's just 1. So when you times by 1 with something, it's always original, the same expression, isn't it? So we are not changing the original question. That's the whole point. Because you can't really just times something and changing it. So, but by timesing it 1 in this way, we can rationalize the denominator. So let's start. On the top, I'm going to put these in a brackets. And on the bottom, I don't know whether you remember the difference of two squares. The formula was something like this. Equals a squared minus b squared. Okay, so that's what these ones are. So on here, I will have 1 squared minus square root squared, something like this. And I'm going to do 1 minus. Now that becomes now 2. Okay, so what I've got, so now you notice that I didn't really expand this one, so just wait until the end. Now don't rush into expand it. I know you want to urge to just expand something, but just wait a minute for a second. Now it's a minus 1 on the denominator part, so I can put it like this. Now depending on your teacher, they might give you a mark for this, or some of your teacher will like this bit better, so that they will know whether you're aware of that changing sign. Okay, so this is okay, that's still okay, but depending on your teacher. So listen to your teacher and what he or she says about it. Now, second question I'm going to do is the same, but a little bit different. It might be a little bit easier for some, might not be. We will see. 1 plus root 6. Now, you probably have urge to, oh, that's easy. You just times by root 24 on the top and the bottom and rationalize the denominator on the bottom as a 24. Yeah, that's fine. That's okay. That's not a problem. But I'm just going to show you something different here. So what I'm going to do here, I'm going to separate this root 24. Now, do you remember? It's like this. Yeah, so that's what I'm going to do. I want to get rid of this square root on the top. So I'm going to go, now what's a half of 24? 12. Oops. So if I do that, 24 is just like 2 times root 2 times root 12, and that's exactly the same. So what I'm going to do now is I'm going to cancel this 2, square root 2, and then I've got left with 6 and root 12, but I'm going to do something different. On the bottom I got root 12. What's this one? Root 12 is, if I can find a square number with a 12, it'd be 4 times 3, wouldn't it? So I'll get 2 root 3. So I'm going to write it 2 root 3. Okay? And then I will times by root 3 on the top and the bottom. Now you can times it by 2 root 3 here, 2 root 3, but don't need to really, because you just times 2 extra little bits. So here now I will get 2 root 3 times root 3, here root 3 times 1 plus root 6. Okay, so on the denominator I'll get 2 times 3, because root 3 times it is 3. And then I'm going to separate this, so I will get, what's a 3 times 6? 18. So that's a 6 here, and I might just want to simplify 18 here. Now what's the square number that you can think of? 2 times 9, isn't it? And that would be coming out as 3, 2, so plus. Now we can't simplify anything here because it doesn't do anything. So my final answer will be this. Okay, that's okay, that's not too bad. Now quickly, I just want to show you something. With root 24, if we need to simplify this, I'm going to use upside down division. 24 here, and I'm going to divide it with prime numbers, basically 2, 3, 5, 7. But if it's even number, I'm just going to stick with a 2. And if it's something to do with family of 3 or family of 5, I'm going to use that. So I'm going to do 2, so that halves it. Keep going. Okay, so I'm going to pair this up. Okay, so what's happening here is I'll get 24 2 squared times, I'm just going to make it 6. So what I've got is, that's what I've got. So you can use that. Okay, so I mean the easiest way will be finding a square number in that number. You know, one of the factors will be the square number. But if it's not, 24 doesn't have a really square number. I mean here, but not like a nicely square number with a prime. So you could use this. Okay, well done people.